अप्रैल महीने से जो तापमान बढ़ता है तब छत पे जो गर्मी होती है वो पंखे के सहारे कक्षा में और फैल जाती है, जिससे कक्षा में सामान्य रूप से बैठकर शिक्षा ग्रहण करने भी तकलीफ होती है।
पढ़ाई में मन नहीं लगता था और ज़्यादा मार्क्स नहीं आते थे, बहुत पसीना आता था।
पंखे की हवा भी बहुत गर्म तो रहती है क्योंकि हम फर्स्ट फ्लोर पर रहते हैं ऊपर, और गर्मी नागपुर में बहुत ज़्यादा है।
During peak summers, this is the case with most of the buildings. In such high temperatures, the basic facilities become irrelevant. To tackle the situation, a simple experiment was conducted under the Innovation Challenge program of the World Bank. This experiment was a part of the project by IIIT Hyderabad and VNIT Nagpur, which involved the transformation of dark roofs into cool roofs.
Cool roof is a very simple technology in which we coat the top surface of the roof with highly reflective material, and the basic idea is that we reflect the incoming solar radiation back instead of absorbing it. A normal dark roof would have a reflectance of about 0.3, that is, it will absorb about 70% of the heat. A significant amount of that heat will be transmitted to the space below that roof. In case of a cool roof, the reflectance would be about 70%. So, it will absorb only about 30% of the solar radiation, and therefore, less heat would be transmitted inside the building. So, basically we are reducing the heat transfer into the building by reflecting more of the incoming solar radiation. At the start of the experiment, the first question that was to be addressed was that what kind of buildings should we look for where we should perform this experiment. And we had several deliberations with various stakeholders and with some NGOs, and we found that school is a very good candidate because the children are studying, and the timings of the school and the summer break are governed by the outdoor temperatures.
To begin with, we selected something close to 4 to 5 schools in the rural area because it's easy to study the schools. We will have better access.
But there were certain roof criteria to be looked upon for such an experiment.
Particularly for this experiment, we require an even surface and clean surface, and we don't need any shadows around this building. And if you look at this roof, here we have some roof is getting peeled out. When you apply a coat, even that coat will peel out. And if you look at this, there is a large parapet wall which will give you a shadow in the evenings or in the mornings. And even this surface is not even, so it's uneven, and you can see that there are some up and downs in the roof. And if you look at this place, there is a mark you can see. This is a water logged mark. So this is not good for the experiment. Generally, when you apply coat, here these marks will come onto the white paint. And these are the issues we face in various other sites.
So based on this, we kind of shortlisted the school which we decided that we will study because it had a wonderful roof surface. The drainage was good. We got 2 rooms with identical dimensions, with similar kind of orientation and identical thermal environment.
Various considerations were there to evaluate which would be a good candidate, and we were lucky to get a good school. It's not that easy always to find out a building with identical spaces.
Finally, 2 schools fit the bill. The Valmiki Nagar Hindi Madhyamik School, situated in Nagpur, Maharashtra, and Zilla Parishad High School near Hyderabad were selected for this experiment. After the selection of the buildings, various monitoring equipment was installed in both buildings to analyze the thermal environment in the rooms. Indoor air temperatures were measured by the temperature probes in both the rooms. The leaf probe installed underneath the roof surface measured the under-deck temperature. The outdoor surface leaf probes recorded the over-deck temperatures. The weather station was installed on the roof of the school to collect the local weather data. It measured the temperature, relative humidity, and solar radiation.
There were issues of theft as far as Nagpur is concerned, so we decided that we would place the weather station in VNIT itself, so that the same weather station data can be used for a school which is within the radius of 2 kilometers.
The data logger installed in both the rooms collected and logged the data from all the sensors and the weather station. But the experiment was not devoid of problems.
Suddenly there was a huge outpour of rain which affected the sensors, and then suddenly our overdeck temperatures started behaving abnormally. So we had to go again through that same procedure of testing sensors and installing them.
After the installation of the equipment, both rooms were monitored for 1 week in their existing condition. The rooms with slightly higher temperatures were selected for coating in both locations with a cool roof material.
So there's a wide spectrum of products available. One of the simplest things is the whitewash. From traditional things to new generation high-end coatings, membranes, and there are so many other tiles and various other products available. When somebody is buying a cool roof material, I would say he has to look carefully about 3 properties. One is what is the reflectance. So how much of the solar radiation the product will reflect. Generally it is a number between 0 to 100. Higher it is, better it is. The second thing one has to look for is the emittance. The emittance should be higher. It is generally a number between 0 to 1. Higher is the emittance, better would be the product. The third and very important aspect of cool roof is how does it age. So over the years, how good is the roof in maintaining both these properties. So not only should one consider the initial reflectance and emittance, but one should consider the age reflectance, something like maybe 3 years or 4 years, how does it behave.
For 3 months, data was collected to determine the increase in total comfort hours in the room with cool roof compared to the normal roof. The on-site data logged in the data loggers were collected on the weekly basis. This data was analyzed through adaptive thermal comfort method.
Results of the project have been very promising. We have noted significant reduction in the indoor air temperature.
In Zilla Parishad School in Hyderabad, the room with the cool coating saw a reduction of 4.3 degrees Celsius in indoor air temperatures as compared to the uncoated room. In Valmiki Nagar School, the indoor air temperature was reduced by 3.3 degrees Celsius over the room with a dark roof.
Though experimentally we can see that there is a reduction in the room air temperature, but it's very important to find out whether the occupants are comfortable or not.
पंखा तो वही है पर ठंडा हवा आ रहा है, पता नहीं क्यों।
पेंट ऊपर करवाए तो उसके कारण ठंडी हवा आती है और हमारा पढ़ाई में भी मन करता है।
अब जब कूल रूफ हो गई है तो उस रूम में तो बहुत अच्छा लगता है, हमें ठंडा महसूस होता है, लेकिन बाकी की कक्षाओं में हमें आज भी गर्मी महसूस होती है।
वातावरणीय टेम्परेचरपेक्षा टेम्परेचर त्या 2 खोल्यांमधलं कमी झालं। जर पूर्ण शाळेतल्या रूममध्येच आपण असा प्रयोग केला तर त्याचा फायदा सर्वांना होईल।
In number of ways one can look at its advantages, not only just the thermal comfort, but one can increase the output or usage of the building itself.
The beauty of this technology is that it is so simple and so easy to implement that It can be implemented in rural, it can be implemented in urban areas, and we don't need to have a big infrastructure to implement this technology. So it is to be done at individual level, every building level it can be done, and whoever does this coating or whatever white material that are available, they get the benefit.
The change in the indoor environment was quite visible.